On guys, in this video we are going to see an example of free untimed motion initial value problem, and in this particular problem we have asked to find out the equation of the motion. Now let's look at the given informations. Here we have the force provided, that is 400 Newton, and also we have the spring stretch, that is 2 meter, s is equal to 2 meter, and also we have the mass, that is 50 kilogram, and in the question they have mentioned this is released from the equilibrium position with an upward velocity of 10 meters per second, and when it's released from the equilibrium position it means the displacement is 0 when the time is equal to 0. So from this one we can say x of 0 is equal to 0, and also they have mentioned this is released upward velocity of 10 meter per second. So if it's upward velocity, that's negative. If it's downward velocity, that's positive. So x prime of 0 is going to be negative 10 meter per second. Okay, now we have all these informations. Now in order to find the equation of the motion, we have to use one of these second order differential equation. All of them are equal. It's up to you to choose one of them. Now let's choose this one. If we choose this one, we have to know the spring constant and the mass. We know the mass, that's here, but to find the spring constant we have to use this equation. F is equal to Ks, right? Since we have the force and stretch, we can use this to find out the spring constant. Now let's go ahead and do that. So F is equal to Ks, therefore K is going to be equal to F over S, right? So F over S, our force is 400 Newton, force divided by the stretch, so 400 Newton divided by 2, that's going to give us 200 Newton per meter. This is going to be our spring constant. Now we have the spring constant and the mass, so we can go ahead and write our second order differential equation. Now this means x double prime. So x double prime plus k over m. K is spring constant, that is 200, divided by the mass is 50 kilogram, times x is equal to 0. And if you simplify this one, this is going to be x double prime plus 4x is equal to 0. And we know that when we have second order differential equation, to find the general solution of a second order differential equation, we use the arbitrary formula, and if we have double prime we replace that one with r square, and if we have single prime like x prime we replace that one with r, but we don't have that one. And if we have 4 times x, we replace that one with a constant in front. So here we are going to replace this one with r square plus 4, that's equal to 0. And if we try to solve this one, this is going to be r square is equal to negative 4, and therefore r is equal to square root of negative 4. Now we are having negative value inside of square root, so this is going to be a complex number, and when we have a complex number we replace this negative inside with the I square, like negative 1 is equal to I square, so this is going to be I square times 4, so that's going to become 4i, right? 4i. And if you remember the complex number pattern, that's going to be like alpha plus or minus beta I. In our case this is 0 plus or minus 4, because this is plus or minus 4i, right? Plus or minus 4i, and from this one we can see our alpha value is 0, beta value is equal to 4. Now we can go ahead and write our general solution for this differential equation. Now there are 3 types of general solution. Like if we have equal real roots, we use a different equation, but when we have complex number, this is going to be our general solution pattern for a differential equation. Now this is the one we are going to use. Now from this we already know alpha is equal to 0, so e power 0 is going to be 1, because e power alpha times x, that's going to be 0 times x, so that's going to be 1. So we don't have to worry about this e power part. We can just write c1 cos beta x and plus c2 sin beta x. So our general solution for this differential equation is going to be x of t is equal to c1 cos beta, and we are using function of t, so this is going to be beta t, and then plus c2 and then sine beta t. So this is going to be the general solution for this differential equation. Now to find the particular solution, we are going to use these two informations. We know that x of 0 is equal to 0 and x prime of 0 is equal to negative 10. Now let's use this one first. Now let's copy this one down here first and then use it, right? we know that x of 0 is equal to 0, and also we know that x prime of 0 is equal to negative 10. And if you apply x0 is equal to 0, we know that cos 0 is equal to 0, right? When times 0, this is going to be 0. So cos 0 is equal to 0, sine 0 is going to be, no, cos 0 is equal to 1, sine 0 is going to be equal to 0. So this part will be eliminated. So we will only have this part. From this one we know that x of 0 is 0. So 0 is equal to c1 times 1. I'm just plug t0 in this equation. Okay, I'm just using this equation. So c1 times 1 is equal to 0. Therefore c1 is equal to 0. Now to find the c2 value, we have to find the derivative of this one. Since we know that c1 is equal to 0, we don't have to worry about this part. We can write our new equation. That's going to be x of t is equal to c1 is 0. So this is the only part that's going to remain, c2 sine beta t. And if you take the derivative of this one, this is going to be x of t, x prime of t, and this is going to be, okay, c2 sine beta t. And we know that beta, okay, I made a mistake here. This should be 2 here. Okay, this should be 2, 2, 2, and also I have to replace this beta with 2. Okay, so this is going to be 2, 2t, 2t. Now here also we are going to have 2t. The first step is correct because no matter what, beta or whatever, you plug zeros for t, that's going to be sine 0 is going to be 0 anyway, right? So this is 0, and this is going to be the equation that remains. Now if you take the derivative of this one respect to t, this is going to be a chain rule, because we have to take the outside derivative and also we have to take the inside derivative. And if you take the inside derivative of this function, that's going to be just 2. So this is going to be 2c2, and derivative of sine 2t is going to be cos 2t. So cos 2t. Now we can use this formula, the second formula, and from this one we know that when time is equal to 0, x prime of 0 is equal to negative 10. So x prime of 0 is we are going to use, that's negative 10 is equal to 2c2 cos 0. Okay, cos 0 is equal to 1. So from this one we know that negative 10 is equal to 2c2. Therefore c2 is going to be equal to negative 5. Now we have this value, so we can write our final particular solution. The particular solution for this differential equation is going to be x of t is equal to, c2 is negative 5, so negative 5 sine 2t. Okay, so this is going to be the particular solution for this differential equation, and this is the equation of the motion. And that's how we do this kind of problems. I hope this helps. Thanks for watching.